Hi students, now for this chapter you're going to learn about gravitation. Okay, it's an exciting chapter, just it's a bit long, especially when it comes to calculation. So get your calculator, pencil, paper set in front of you. Okay, now first of all, what are the things that you're going to study in this chapter? Three things in total. You're going to study about Newton's universal law of gravitation. You're going to study about Kepler's law, there's three Kepler's law. And you're going to study about man-made satellites. And man-made satellites is just divided into two. Okay? Now in total you'll have about 8 to 9 formulas that I'm going to derive and show you. But my advice is make sure you have your calculator, your paper, pen in front of you. There's a lot of calculation that we have to do. Okay? Now let's get started. Guys, first, if you look at the word gravitation. Okay, gravitation, or gravitational force. Gravitation, or gravitational force. It is interchangeable with gravity. However, if you go a little bit deeper, guys, there's a difference between gravitation and gravity. Okay? Now, let me explain to you what are the differences. So when you talk about gravitation, gravitation is basically a universal force. Okay? It's a universal force over here that acts between objects of a certain, or objects of a mass. Okay? Let me give you an example, guys. Now let's just say you have this planet A. Okay? Planet A has mass m1. And then you have planet B. And planet B of mass m2. Now there is a force of gravitation that pulls both objects towards each other. And the value for that force of gravitation is the same. Now let me repeat that again, guys. So if you ask me, sir, what's gravitation? As I say, gravitation is a universal force. And it's not only a weak force, guys. It's a weak force. Gravitation, it's a universal force. So you can see I've given you two objects. Okay, let's just say planets. They have their own mass. And there is gravitation pulling both of these planets towards each other. The value for that gravitation is the same. Okay? Now, let me give you another example. Let's just say you have a tree. Okay, you have a tree. Pokok yang paling cantik di dunia. Okay. And normally when I ask my students what tree is this, I think you have the same answer in your mind. Most of them will just tell me it's an apple tree. Now, so you have your apple tree, okay, on planet Earth, and you see the force of gravitation of apple on planet Earth. The force of gravitation of apple on planet Earth and the force of gravitation of Earth on the apple is the same. Okay? You heard what I said there? The force of gravitation of the apple on planet Earth and the force of gravitation of Earth towards the apple is the same. So technically meaning that the Earth and the apple has to move towards each other. Am I right? Technically meaning in that sense. But why you see that only the apple is falling down? You don't see the Earth moving towards the apple. It's supposed to move towards each other. Now the reason why, remember I told you, gravitation is a weak force. And because it's a weak force, what happens over here? The mass of Earth is so huge that you are unable to see the effect. So you can ignore the effect of the Earth as moving towards the apple. The apple, the mass is so small compared to the Earth that you will obviously see the apple falling down. Okay? So this is the concept of gravitation, and we can calculate gravitation using this formula. But I'm not done yet, guys. Now, remember I told you there's a difference between gravitation and gravity. Now, when you talk about gravity, I'm asking you, what is gravity? Now, gravity is the force that pulls objects with mass towards the center of the Earth, isn't it? So, if let's just say, okay, let's just say, I'm asking you over here like, okay, this is planet Earth, and you have an object on the surface. So this is the surface, guys. So this is the surface of planet Earth. Okay? So you have your force of gravity pulling the object towards the center of the Earth. Okay? Now just for your just a note that I need you all to understand. You see, on the surface, we assumed, not we assumed, we took an average. The gravity to be 9.81, okay, newtons per kilogram. So this is the value that we have taken, 9.81 newtons per kilogram. Now, if I'm asking you, what is the gravity at the center? What is the gravity if you are at the center? At the center, the gravity is 0 newtons per kilogram. And as you move higher and higher, as you move away from planet Earth, the gravity increases, becomes higher and higher and higher. This is a note that I want you to understand. So, if you look at this point here, the gravity will be 9.81. And gravity is a strong force. Gravity is a strong force. So, gravitation, universal force, weak force. Gravity is a force that pulls an object towards the center of the Earth. And that is a strong force. And you look at the formulas, guys. For gravity, the formula is F equals to mg. How many mass are you using? You're only using one mass here. That's just m. But if you look at gravitation now, I want to talk about the formula for gravitation. Now look at this. This is our Newton's universal law of gravitation. You can see this formula here given in your textbook. Okay? Now I want to explain this formula. It's a very simple formula, guys. F is your force of gravitation. So this is your gravitational force or your gravitation. Okay? And if you look at the formula here, you have G, which is what we call as a gravitational constant. This gravitational constant is given to you in your exam, so you don't have to worry. So you've got gravitational constant, mass m1, m2. So again, taking the planets, you got planet A, you got planet B. Okay? So planet A has mass m1, planet B has mass m2. Now exactly in the middle, okay? Now the distance from the middle of these two planets, we are going to label it as R. The distance from the middle of two planets, we are going to label it as R. And your gravitation force or gravitational force is this. And remember what I told you? That the gravitational force is the same. Okay? Now, if you look at your definition for Newton's universal law of gravitation, now take it easy, relax, biar cikgu terangkan dulu. Look at this formula, guys. Now, this is mathematics. Normally, kalau macam ni, kita panggil directly proportional. Okay, directly proportional, isn't it? Kalau macam ni, we say inversely proportional. Proportional, isn't it, guys? So, kalau kita tengok, if I'm asking you, guys, can you tell me what's the definition for Newton's universal law of gravitation? Okay, so Newton's universal law of gravitation basically states that if you look at this, your gravitation force, okay, is directly proportional. You see this one? Your gravitational force is directly proportional to the product of mass. This is the mass. Product of mass means hasil dalam. Product of mass of the two bodies. So your gravitation force is basically directly proportional to the product of mass of the two bodies. Okay? And it is inversely proportional to the square of the distance. So, square of the distance. Square tu basically power tu lah guys. Square of the distance over here between the middle of the two planets. So, here kita kata directly proportional. Here inversely proportional to the square of the distance between the centers of the two planets or of the two bodies. Okay? Now, when you talk about Newton's universal law of gravitation, guys, try not to remember the definition, try to understand. Just put this formula here and ask yourself, if like this, it's directly proportional. So directly proportional to the what? Directly proportional to the product of the mass of the two bodies. And like this, saya kata inversely proportional. So your gravitation force is inversely proportional to the square of the distance. Kan kuasa dua? Square of the distance between the centers of two bodies. Alright? Now for the next video, I'm going to show you some calculations on how to use your gravitation formula. Okay?